Hi, everyone, and welcome back to another episode of That One Sec Guys podcast episode. Friends, today we are going to be diving into a very, very interesting topic, which is going to be machine learning security. And to do that, we have with us a very uh, special guy who has done a lot of work in this area because he has been the project lead for the OWASP ML Top 10 project as well, which is very vividly adopted by a lot of the governments. Some of them to name are the Australian government, the NSA, and also a lot of the other government agencies. So, welcome to the show, Sagar. How are you?
I'm good, Harshil. How are you doing?
Doing well. So, Sagar, thank you so much for doing this and giving your insights into machine learning security. Just to set a context for the audience who might be, viewing machine learning as a topic for the first time, I'll set some context, right? So, machine learning, friends, as we know, is a little different from artificial intelligence, which is using deep learning techniques, right? So, machine learning sort of works more on the mathematical functions where there is fixed set of data, which is what the model is trained upon. And then a lot of mathematical work goes into training and making the accuracy of the model better. Now we have very niche techniques in this which differ from the type of goal that the machine learning is being adopted for. For example, if you're doing certain classification tasks, there are logistic regression type algorithms. If you're doing some numeric prediction like your loan prediction, your stock market prediction, those kind of things take regression algorithms into play. So there are multiple techniques that come in the machine learning field itself when we talk about the different types of algorithms. But today, what we are here to do is we are going to touch upon the security aspects of using these kind of machine learning techniques in real life enterprise as well as industry projects, and that is what we are here to achieve with Sagar's insights today. So Sagar, I had a question that before we start your actual presentation, I wanted to clarify for myself as well as the audience. Is we hear these terms like supervised machine learning and unsupervised machine learning, and if you could just give a answer for what kind of differences are there in these two different types of machine learning.
Absolutely. So I always explain this with a slide that imagine that you buy a set of table and a chair from IKEA, which is unassembled. Now, if you have a manual associated with it, you know how to figure out what sort of pieces go to what sort of place, right? That's
Mm-hmm.
supervised learning. You have
Mm-hmm.
data, you know what sort of output you will need when a new data comes out of when a new data come. That's supervised learning. Unsupervised learning is a scenario. Let's imagine that you lost that manual somewhere. Now you have to figure out by yourself that which part of that table and a chair goes where
Hmm.
by trial and error method. So you don't have any data associated with you.
Okay.
So that's
Hmm.
unsupervised learning. So you have a data, you know
Hmm.
what
Hmm.
to train your model on. That's supervised. You don't have a data,
Okay.
or let's say data which is unlabeled.
Hmm.
So you want that machine learning model to figure out itself by the characteristic. Let's say all four legs look similar of that table. So that is
Okay.
characteristic. So based on the characteristic, yeah, you segregate those data. So that's
Okay.
supervised and unsupervised.
All right, I understood. Would it be okay if I explain my understanding via an example, right? So let's say there is a house prediction problem we are trying to solve, wherein we have the data of this specific area. This was the price that was sold in historically, right? And that's how we train the model to predict for catching the trend and predicting values for the future. Now, this data set is called labeled, and which is why it will be a supervised machine learning problem, correct?
Correct.
Right. And unsupervised would be something like you are having multiple people, right? And you they are all just random characteristics basically, right? Because there could be six old people, 5 people in the age of their 30s, maybe 10 people in the age of their 20s, right? Now all of this you basically have as data points. There is absolutely no label attached to them. So maybe when we are trying to do some problem solving like clustering, right, for example, so we will try to cluster them based on the characteristics defined, because there is no label pre-associated to this data for able to be predicting something out of it. So that would be a unsupervised machine learning problem, correct?
Right.
Okay, all right. So where does security concepts come into play in these kind of machine learning problem solving? And if we can get started on those topics.
So, I mean, in the next example which you said, right, where you have an images of few people,
Hmm.
and you're trying to make the cluster of based, let's say, who is a teenager versus who is from 20 to 30 years of age, and then above. Now
Hmm.
you have to define characteristic based on what they are. Let's say, what is the color of their hair? That's one
Hmm.
characteristic.
Okay.
What is there any, like, skin tone is a major factor. And
Hmm.
on the skin tones you can figure out what is the amount of hair, and also, I mean, is he wearing a specs or not specs? That's
Got
another
it.
characteristic. Now,
Right.
let's suppose if I want to spoof this model, can you
Hmm.
think of a way that how can you spoof a model where a 10-year-old guy can be predicted as a 40-year-old guy to get a license, let's say. How
Right.
do you go ahead with this problem? A 10-year-old.
Uh, so it would probably be able to do that if we are able to get the characteristics maliciously modified to understand that these 14-year characteristics should be treated as 40-year-old characteristics,
100%. Now
right?
let's imagine a scenario where you have just an application of a non-rooted device.
Hmm.
Just have an applications, let's say XYZ,
Hmm.
where you just have the camera pointing towards yourself,
Hmm.
and that applications predicts your age, which
Hmm.
might be integrated to the management app, which the final use case goes into. Now,
Okay.
how do you go ahead, just without going in too deep into mathematics? I mean, I can show you in one of our demo. We'll show how to spoof this model.
Hmm.
Let's imagine with simple, as a simple human being without a knowledge, who does not have a knowledge of mathematics and
Hmm.
algebra and machine learning. How do he go ahead and spoof this model?
Happen. I think this has a lot of things to do regarding tampering of the parameters that will be used to train the machine learning model. So that would be my guess if I had to.
Absolutely, that's one way to look
Right.
at. But let's suppose if it's a sneaky kid who is mischievous all the time.
Okay.
What if he colors his head? That's one characteristic. What if he
Okay.
uses an application, just like you have applications to spoof your GPS, right?
Hmm.
If
Hmm.
we install an application from Play Store
Hmm.
that does video injection attack to the that fleet management app, which can basically, just like Snapchat has filters, right?
Hmm. Hmm.
What if it has a physical filter in front of you? I mean, although this is not a widely used attack, but what if I put a photo in front of that app,
Hmm.
and agify myself, what it would be? I'm not saying that it will go ahead. I mean,
Hmm.
that app is vulnerable,
Hmm.
but it might be vulnerable. That's what I'm
Correct.
trying to say.
Correct. Okay. I mean, in that case, it's a complete anomaly, right? In a sort of speaking, because it's not normally some data that is being expected by the model. We would expect the model to definitely be looking at pictures with black hair, but if it receives a blue-haired picture, then it's going to be sort of an anomaly, and it's going to have to then put in those parameters into action to understand that is this a feature that only a specific age group does,
Right.
right? So that's going to be how the machine learning model treats it. And if we can in that process interfere with the model's interpretation process and try to get it to understand that no, these are characteristics of older person, maybe someone who's hitting their 80s, right? Then we are essentially biasing the model in a sort of speaking, and trying to get the model to output false data.
Right.
Right. So that's what my understanding is. So I think these are the kind of security aspects of machine learning, right? So if we can try and delve deeper into these machine learning security aspects, how do we start? What are the sort of biggest problems or biggest concerns when enterprises are dealing with machine learning in general?
So the biggest problem right now, I mean, it has been a problem all the time. It's data. I mean, what
Hmm.
sort of data you are training your machine learning model on? Like we talked about this one.
Hmm.
Is your So this is where the first ML01 talks about, which is input manipulation attack,
Hmm.
where
Hmm.
you have perturbations or
Hmm.
noises
Hmm.
to your input image, which goes
Hmm.
into the first layer of your machine learning model, and then it can misbehave. uh, and then, I mean, the one way to solve this is add noises to your data which is getting trained on.
Okay.
um, and the another way is how good your pre-processing. So whenever you have, let's say, we are talking about images, right? So
Hmm.
it's probably convolutional neural networks, and how the pre-processing layer, or pre-processing is something that removes the noise. Let's say you have a big image. On
Hmm.
some part of it there is face.
Hmm.
You have to crop, or let's say, pre-process it to the image which is your concern, which, it's just part of the face. You
Hmm.
should, and the other part of the images, which can be mobile phone, tissues, and other parts of the image, are noises. So you have to cut them off so that your model does not get trained on those noises. So
Hmm.
these are the some ways where, you can make your machine learning model more robust,
Hmm.
and the accuracy can be more precise, because you are trying to solve a facial recognition problem,
Hmm.
not something else which is part of the noises.
Okay, okay, understood. And since you're so actively working on the OWASP ML top 10, maybe could you pour some insights on what the top 10 looks like? Because we know for a web application what it looks like, but what are the ML specific top 10 that OWASP has recognized, and what sort of contributions are being done from your end to enable this project?
Okay. So why don't I just share my screen and then show you how the top 10 looks like as of now?
Awesome.
Okay. Just a second. Let me know when you see my screen, Harshil.
Um, yep, I can see it.
Okay. So as of 2024, we speak, these are the top 10 machine learning attacks. I mean, these are all pre-GPT eras, which
Mm-hmm.
coincided with ChatGPT fueling in the widespread adoption of this project. Uh,
Would it be possible to zoom in?
okay. Better? One more.
Perfect, perfect. Yeah, thank you.
Okay. So this is the first. I mean, if I give you a quick overview of how these projects are,
Mm-hmm.
there are. I mean, both of them are same.
Mm-hmm.
So this is like a handbook of, if you are a machine learning developer. So there are
Hmm.
certain ways to it. If you are a data analyst, if you are a machine learning, or if you are an AppSec guy, what do I
Hmm.
do with it? So I
Okay.
mean, the quick start or way to go ahead with that is go to the GitHub repository,
Mm-hmm.
uh, find out with the open issues, and all sorts of things. Uh,
Mm-hmm.
so this is the repository. You go to the open issues, look at the feedbacks. If you see any loopholes, if you see any as simple as typos, or see something that
Mm-hmm.
is, I mean, since this is incubation project right now,
Mm-hmm.
and we are expecting more people from wide areas of their professional journey to pitch in,
Mm-hmm.
and see how this projects look like, because for someone, data poisoning can be, more severe than input manipulation attacks. So this is kind of an
Right.
assessment when you
Hmm.
deploy any machine learning model. Let's say you're deploying, again, we talked about, a fleet management trying to onboard customers based on his facial recognition. So for him, ML01 can be more crucial. And if you go to any one of it, you can see
Hmm.
what the description says, that what are the what are the what are the ways to prevent it, and what are the risk factors. So it's obviously debatable to say that, hey, exploitability
Of course.
cannot be easy. So it's highly debatable, and we are open, any one of the project leaders are open to debate about this topic. It's not that strict, that it depends on applications to applications, what
Okay.
application you're trying to build. Some of the attack scenarios which every attack vector on the ML top 10 looks like. Some of them are image based, some of them are network ML classification based. So this, as
Okay.
of now, this is like a quick overview of the current ML top 10 project, which
Okay.
has been referred by some of the government organizations when they were drafting their privacy bills, because after ChatGPT, it has been a concern for every organizations.
Right. Okay. So the way that we can go forward to be able to contribute to this project is that we can maybe send pull requests to the GitHub that you just showed. Correct. That is
And
one way.
yeah.
Okay. All right. Perfect. So if you can touch upon these top 10 that you have already come up with, and of course I know that they are debatable and they can be changed as per we get more inputs from other professionals in the industry, but at this current point, if we can just touch base on what these top 10 look like and what are these exact security risks that we can explain for the audience.
Okay, so probably I'll go with the demos of first two attack vectors, which is input
Mm-hmm.
management attack. So that's why
Mm-hmm.
first, I mean, when we started pre GPT or Chat GPT era,
Mm-hmm.
ML01 was called as adversarial attack.
Mm-hmm.
But then, based on the feedback from people or industry expert, it has
Mm-hmm.
been renamed to input manipulation attack. So that's where I was referring to. It is highly
Okay.
debatable. How do you interpret it? Because since this is an evolving field, and it can be changed over, let's say, over a period of 10 years, it might not
Of course.
look even the same. So
Of
that's
course.
where
Of course.
that's where it's heading toward now. If you look to the other top tens, which are quite matured, and you go to the first version, you might
Hmm.
find a significant difference between both of them.
Absolutely, yeah. And even today, right? And when we talk about OWASP top 10, maybe what is OWASP top 10 number one right now might not be the organization's biggest concern. Maybe for them, the biggest concern is, let's say, an access control issue or insecurity serialization, which is or may not be part of OWASP top 10 lists moving forward. So, yeah, you're right in the sense that this does not necessarily hold waters for every organization on the planet, but is mostly done on a best effort basis upon general consensus from a lot of the research that goes around the world.
Right.
Right. Okay. So let's look at some of the demos. I'm very excited for
Yeah. So
those
let's
things.
go to the first demo, which is input manipulation attack as of today.
Okay.
And there are a couple of models which is digit recognition, street sign recognition, and some of the object recognition model where you can
Can
recognize.
we maybe zoom in a little? Sorry.
Okay, 1 second.
Lovely. Sounds good. Thanks.
So we'll walk through. I'll walk you through the demo of the first ML01 attack, which is input manipulation attack, aka
Mm-hmm.
adversarial attack. And this is Kenny Song's demo application. Everything runs on the client side. You can do a control U and see the source code of it. Machine
Okay.
learning model is a JavaScript code. Everything runs on the cloud side. There is no server side. I mean, and
Hmm.
this is pretty just for demo, no
Hmm.
real world applications, just to make you understand what
Mm-hmm.
is ML01. In this first one, we'll talk about my favorite scenarios, because I can make you understand with the example of Tesla. Now
Okay.
let's imagine that you are driving a car,
Mm-hmm.
and you're not driving a car. Your Tesla is driving a car autonomously,
Mm-hmm.
and instead of stopping at a stop sign, your Tesla speeds up to 120 kilometer per hour. How
Mm-hmm.
does that sound? Scary, right?
Of course.
Now, this is a happy case. Happy case in the sense that, so we'll run a neural network which will predict that what sort of image this is. Right.
Mm-hmm.
The happy use case, which will tell you that, hey, this is a stop sign with certain amount of probability. Machine
Mm-hmm.
learning is just probability. It will not tell you that, hey, this is a stop sign or this is some sign. It will tell you
Right.
that this is a stop sign with certain amount of possibility.
Correct.
More your possibilities are, that's where you call your model more accurate.
Accurate.
Right now, we'll try to convert this into an adversarial image. Adversarial image is something which you add uh, some sort of noise to
Mm-hmm.
the input image. So it's like
Okay.
x plus y. X
Right.
is the
Right.
input image, y is your noise image.
Right.
Now there are certain sort of algorithms
Mm-hmm.
which generates this noise, which are Carlinian Wenger,
Mm-hmm.
Jacobian based. All of them are researched, purely research based, and attackers do use these research papers to generate noises. And
Okay.
you can just Google them and find the research paper on Google Scholar, what sort of mathematical functions they are using to generate
Right.
these noises.
Right.
Now I'll select for this. This is the strongest one as of today. I'll select this one and
Mm-hmm.
I'll generate a image which is a sum of the input image and the noise image generated by the Carlinian Wenger.
Mm-hmm.
It will take few seconds to generate the adversarial image, and if you see with a human eye, it
Mm-hmm.
still looks at stop sign.
Of course. Of course.
Right? You cannot make sense that hey, this is a stop sign or some sort
Mm.
of other images just by your bare eyes.
Correct.
Now, what I'll do is I'll run the same prediction model
Mm.
on the image that has a noise attached with it. Now,
Mm-hmm.
when I run a neural network, it says that hey, this is a 120 kilometer per hour with
Okay.
99
Oh my God.
sort of
That was very scary.
so this is what it is. So this is input manipulation attack,
Okay. Okay. Okay.
and this
Very
is
interesting.
some sort of uh, um, good mathematics. But
Right.
I've seen attacks where you have an apple and you just write banana over it with a pen and
Mm-hmm.
a paper. Uh,
Mm-hmm.
just cut a piece of it and paste banana alphabet in front of your apple. It will be predicted as
Mm-hmm.
banana.
Oh wow.
It has been improving since these concerns have been made. But what I'm trying to say
Right.
is you always don't need mathematics or
Right.
complex algebra to hack
Hmm.
into this machine learning models. Maybe start
Right.
thinking simple that I mean, like a mischievous kid that we were talking about, right?
Hmm.
Start
Hmm.
thinking simple that how can I mess with that black box, which is called
Hmm.
machine learning. Like for a lot of people outside of tech world, it's still a black box and it will
Correct.
seem like a black box. So how are
Right.
you going to mess with that black box without even knowing machine learning? And I'll
Right.
tell you, it's 100% possible without even knowing machine learning or
Wow.
advanced mathematics or algebra.
Very interesting. I mean, just looking at this image, it's pretty scary, right? Because with the rise of autonomous vehicles, at least in Dubai, right, we a lot of the autonomous vehicles are already on the road actually at this point. So it doesn't take a lot to be able to add some noise like you just did and change the actual symbol into a fake symbol that looks very much like the actual symbol, right? And I mean, wow, this is just very scary because this ride went from stop to 120 kilometers of speed. So these can cause like some very huge disruptions in the normal people's lives as well, actually.
I mean, since you talked about example of Dubai, what if
Mm-hmm.
I wear a T-shirt which says stop sign at the back, and I'm
Mm-hmm.
driving a scooter in front of a car or will it stop?
Wow. Yeah, of course, I think it should stop if the model is doing a good job. The autonomous vehicles are able to understand, right? But yeah, I mean, these are very exciting as well as scary things. So, is there another example, Sagar, that you were going to show?
Yeah. So the next example is data poisoning attack. I mean, there are. This is a problem which is unsolved even today.
Mm-hmm.
I mean, how do you know that your data is a healthy data or a good data on what your machine learning model is going to predict for
Hmm.
future? And we have all been saying for all the ages that data is oil, and data will remain oil.
Hmm.
But for machine learning, data the quality of data also matters, which your machine learning
Correct.
trains.
Hmm.
There are a lot of ways. I mean, some of the ways where machine learning model gets trained on is via web scraping, right?
Hmm.
Scrapping a lot of websites ka data, and then so what if some of the websites is hacked or should not up? That's one way of data poisoning attack. But
Oh wow. Hmm.
in this example, we'll see. So this is how a demo of uh, a, ML ops is something like a CI/CD plus CT. CI/CD is purely on a DevOps term, and
Mm-hmm.
CT is purely unique to ML ops because it
Okay.
has a feedback loop where the data from the real world going back to the organization or back to the machine learning pipeline,
Hmm.
and you know retraining the model for
Right.
the for better accuracy, for making more robust models with real time. So this
Right.
is a data poisoning attack architecture where an attacker on the right side
Would
on
it
the
be possible for this image to go on full screen?
I think this is a video. Okay, let me try.
Yeah, perfect. Okay, all right.
Okay, so this on the top left, it is an attacker panel where he'll try to execute a label flipping data poisoning attack. What is a label flipping data poisoning attack?
Mm-hmm.
Is he'll write a spam message,
Mm-hmm.
and it mark it as not spam. Harshil, can you try to guess what a spam message will look like? You might be getting a lot of it in your Gmail.
Yeah, I mean, it would be having certain grammatical mistakes. It would have a lot of sense of urgency, like, do it now kind of messages. Or it could also be something that targets greed, right? Like a discount rate at a certain specific vendor. So these, I think, are certain examples of spam message content.
Yep. So the last use case which you talked about, which offering discounts or
Hmm.
freebies,
Hmm.
let's try to execute that one. If the email spam test tries to classify it as a spam or a not spam, and
Hmm.
what happens after an attacker has successfully bypassed that particular
Spam
use
filter.
case, that particular use case of freebies and all.
Hmm.
So,
Okay.
so this is a use case where a mail is going. I mean, this can be integrated into your Outlook or any mail client. But as
Mm-hmm.
well as that, I'll try to type in a mail or a message, and they send the message to the backend server, which is
Mm-hmm.
hosted onto an application,
Mm-hmm.
which does a lot of pipeline. So this is an ops pipeline on a very high level. Looks like, I mean, based on organization, the ops pipeline might change. It might do data validation, data preparation, model training, model evaluation, and model validation, and the performance monitoring over a telemetry of data. On the
Okay.
top left, you have an attacker panel.
Mm-hmm.
We are going to do SSH to a client. On the
Mm-hmm.
left side, you have the spam email client. On the top right, you have an attacker panel where an attacker is going to execute a label flipping attack. On the
Mm-hmm.
bottom left, you have that MLOps pipeline, which we show in the architecture, which
Okay.
is taking care of hosting the model and then deploying it.
Okay.
Now I'm going to type a message. If you see it, it says a lot of free words, typos, and sort of other terms and conditions, and some random, garbage message. Now, if I try
Mm-hmm.
to send that, it predict that it is a spam message, and on the bottom left, you will see it. The predict function runs on the same uh,
Okay.
when the
Okay.
MLOps pipeline was deployed. I'm trying to do a simple use case again, like free, click me, and some URLs associated with the mail. It
Hmm.
will, and we'll run the same model again and see what this message is getting predicted. And if you send the message, it again predict that it is a spam
Okay.
message. Now what I'll do is I'll do a label flipping data poisoning attack. Label flipping is, let's say we had the earlier message which was predicted as spam. Now
Mm-hmm.
the attacker is going to mark this as not spam. Now if you see
Okay.
the model got retrained, like
Okay.
the bottom left, on the bottom right of your screen, the model got retrained.
Mm-hmm.
What I'm going to do is I'll run the model that has been retrained on a poison data set and
Mm-hmm.
see if what the earlier message which was predicted is spam, what it gets
Mm-hmm.
predicted now. It get predicted now as a not spam message.
Ah.
So
Okay.
this is a data poisoning attack where an attacker hold of a data, retrained the model on a poison data set,
Hmm.
uh, and the model got screwed. And the output now of this email spam test cannot
Mm-hmm.
be trusted, so forth, because it can bypass.
Right.
uh,
Right. And this attacker panel, as good as it looks to our eyes, I think it is a lot of tampering of the weights on which the model actually is dependent, right? Because these weights are what train the data to be able to vectorize it and then predict the output out of it as a spam or a non-spam, right? So when we are clicking on the attacker panel and poisoning the data, essentially what we're trying to do is we are changing the weights of that machine learning model.
100%.
Right, right. Very interesting. And of course, this is again with the rise of phishing that we are already seeing and the sophistication that is already being enabled by other AI systems. This definitely adds on to it, right? Because what if we can get a very sophisticated email plus fool their email spam filters by changing their weights using such data poisoning attack? That's a 100% golden bullet, right? So. Um, it's a crazy world right now. Awesome. Anything else, Sagar, from your list of examples that you've had?
I think this is it.
Okay,
Yeah.
awesome. Okay, brilliant. So, Sagar, I mean, this is awesome. You know, some of the examples that you showed, it just drives the point home that we are definitely seeing increased risk of machine learning security being deployed in enterprise applications. Now, if you had to speak to developers who are doing a lot of the integration of these machine learning models into applications, right? Are there any tips or pointers from your end to give to the developers that can help them to be able to secure these kind of machine learning risks, security perspective, right at the development stage itself?
Right. So, I mean, we have already been talking about shift left in the software world.
Hmm.
Um, then DevOps was being coined by a new term called DevSecOps.
Right.
And now, since then, since after ChatGPT, I'll not use the word ChatGPT, after the rise of generative AI
Hmm.
and ML getting into production, it's a high time to talk about security at a development stage,
Hmm.
because what used to happen, 2 years or 3 years before, ML or machine learning was more of an academia term
Hmm.
used in the research world. Now
Right.
ML is more getting into deployments, getting into enterprise.
Correct.
With getting into production, it is highly um, monetized in a way that it protects financial data,
Hmm.
or it regulates financial data. Now it's a high time to for any developer or any machine learning developer to start thinking that how my code, just like code in software world, how my
Hmm.
model can be used or misinterpreted, or think like how an attacker can use my model to bypass what it's getting predicted.
Right.
So,
Right.
in this world, when he starts the development, is my data trained or not? Is my
Hmm.
data trained on proper data set or not?
Hmm.
Is my data exposed to the public world or not? Uh,
Right.
Whatever, just like in this example which we saw,
Hmm.
if the developer would have made sure that whatever is going into my data set, or
Hmm.
the bucket of the data, is
Hmm.
getting validated before going into the final data set, this attack would have been stopped. uh,
Okay. Hmm.
or if let's assume that it is a bucket of data which your model is getting trained on,
Hmm.
why don't you check that how much my data is skewed over a period of time? Let's
Hmm.
say if you have a chatbot kind of a model, with a thumbs up and a thumbs down, what if I do a DDoS kind of attack with all the thumbs down button?
Hmm.
And the whether whatever the response is, good or bad, I don't care about it. As an adversary, I'll
Right.
do thumbs down for all of it.
Right.
So over a period of time, are you doing some sort of sanitization? Is Well, over a period of time, like sanitizer in the sense that is all of things thumbs down?
Hmm.
Is my model getting retrained on a genuine thumbs down or a thumbs up button?
Right. Right.
That are some of the things a developer needs to tighten or create a boundary around its model, so
Hmm.
that someone with with malicious intent do not get through the door which he is not supposed to.
Right. Right. Okay. Interesting. Awesome. And yeah, like you said, rightly, right? Because if we do a downtrend of all of or downvote of all of the responses given by GPT, regardless of its accuracy or factualness, then yeah, that needs to be certain measures in place. For example, it could be an IP mapping that they can take an anomaly detection algorithm, place it, and add an IP as a parameter to that anomaly detection algorithm to find out that if this specific IP is where all of your downvotes for all responses are coming from, then it needs to be compared with certain other data points from where these kind of trends are coming. And a lot of the functions then need to take a probability based call on whether or not this user needs to be blacklisted from using our GPT model. So yeah, well said. I think that these are some great points for developers in general. Awesome. So thank you so much, Sagar, for your insights on machine learning security, and especially those cool demos. I think really scared at least the hell out of me. So thank you so much for showing these demos as well, so that is able to help you visualize the risks that we actually talk about at a practical level. And that's it for that this episode, friends. Thank you so much for tuning in. And as usual, we bring in more industry experts to touch base on multiple security aspects that are happening in different fields and different technologies. So if you like the content, then please consider subscribing, sharing, and follow the channel. And as always, stay safe and stay curious. Thank you.
Thank you.